Welcome to today's inclusive driving video. Today we're looking at stopping distances, which is something you might find difficult to remember for the theory test. Here's how we remember them. A car's overall stopping distance is made up of two components. We have the thinking distance and the braking distance. The thinking distance is the distance that the car travels before you've decided that you need to stop and before you've decided to move your foot to the brake pedal. The braking distance is the distance the car travels when you've got your foot on the brake. If you add those two together, you get overall stopping distance. In this animation, we see a car driving along the road, and we'll see a pedestrian suddenly appear as though they've stepped out into the road. You'll see the car turn orange to represent thinking distance, and you'll see the car turn red to represent braking distance. So here comes the car, and here comes the pedestrian, and the driver has got to react to the pedestrian stepping in the road. According to the highway code, that takes about 0.7 of a second. And now the driver's brain has reacted to the pedestrian, and the driver's decided that he needs to brake. This is the distance it takes the car to come to a stop. You now know that the assumed thinking time is 0.7 of a second. But this is very generous. This assumes that the driver is alert. Let's test how long it takes you to respond. The stop sign will appear without warning. When the stop sign appears, clap your hands as quickly as you can. Remember, in this reaction time, your brain has got to process the fact that you need to brake, and it's got to send a message to your foot to come off the gas pedal and onto the brake pedal. The thinking distance gets longer as you go faster, because the car will travel further in that 0.7 of a second. So why does the braking distance get significantly longer the faster you go? This is because when you start braking, if you're going faster, the car will travel further in the early parts of the braking, and it will travel a shorter distance in the latter parts. Let's say you're travelling at 70 miles an hour. To slow down from 70 to 60, the car's still doing about 65 miles an hour average. And so you will travel a long distance. When you've slowed down to say 40 miles an hour, the car will travel a shorter distance while it gets down to 30 miles an hour. And from 10 miles an hour to 0 miles an hour, the car won't travel very far at all. And that's why the thinking distances increase with speed at a logical rate, but the braking distance appears to increase at a more random rate. Here are the official typical stopping distances quoted in the highway code. These are very out of date, but they are still the official guidelines, so it's what we'll teach you. Can you see an easy way to remember them? If not, carry on listening and we'll come up with a few ways together. The thinking distance is relatively easy, especially if you know your 3 times table. Let's imagine 10 miles an hour was on that table as well. At 10 miles an hour, your thinking distance would be 3 metres. At 20 miles an hour, your thinking distance is 6 metres. For every 10 miles an hour you increase, you add on another 3 metres. 3, 6, 9, 12, 15, 18, and at 70 miles an hour, we have a thinking distance of 21 metres. Now to look at the overall stopping distances. Remember, that's your thinking distance and your braking distance added together. We've got another table here. We've taken the information from the official highway code version, but we've put some extra columns in it. Let's look at what we've done. In the first column, we've listed the speeds from 20 miles an hour up to 70 miles an hour. In the second column, we've put down the official stopping distances: 12, 23, 36, 53, 73, 96. Hey, I'm a driving instructor, I just remember them. In the third column, we've rounded those figures down to the nearest 10. So 12 metres becomes 10, 23 metres becomes 20, 36 becomes 30, etc. up to 96 metres becomes 90. In the final column, we've just taken the 0 off the end and we're just writing down the first digit of that answer: 1, 2, 3, 5, 7, 9. Now let's look for some patterns in this table. The first one we notice is at 50 miles an hour, the approximate stopping distance is 50 metres. 50 and 50. The next pattern that I like to point out is 12, 23, 36. I call these the Weet-Bix numbers because Weet-Bix comes in packs of 12, 24 and 36. And in the final column, there's a pattern there as well. It's all the odd numbers and 2. So we've got 1, 3, 5, 7, 9, 2, and they're all in ascending order. Or if you're a bit of a maths geek like me, you can say it's the prime numbers and 9. And yes, I am calling 1 a prime number. Did you notice how it took longer to respond when you weren't concentrating as much? By remembering those first digits, 1, 2, 3, 5, 7, 9, you'll be able to answer most theory questions on stopping distances. The theory test isn't that mean, and we'll look at 2 examples to show you why. Here's a mean question. What is the stopping distance at 60 miles an hour? Is it 71 metres, 72 metres, 73 metres, or 74 metres? Using our method, we wouldn't be able to work it out because we'd only have the first digit of 7. But theory questions aren't that mean. A more realistic theory test question would be, what is the stopping distance at 60 miles per hour? Is it 23 metres, 36 metres, 53 metres, or 73 metres? Note how the 4 options are sufficiently far apart for you to be able to just look at the first digit. And so counting up our sequence from 20 miles an hour to 60 miles an hour, we know that we need the answer that begins with a 7, 73 metres. So it's all well and good knowing the numbers or being able to work them out for theory test questions, but how does that relate to real driving? How much is 12 metres? How much is 96 metres? We need a visual guide to be able to recognise those distances. A guide that I quite often use is a swimming pool. A standard swimming pool is 10 metres by 25 metres, or you may have one that's 50 metres. So at 20 miles an hour, the official stopping distance is about the width of a swimming pool. At 30 miles an hour, the official stopping distance is about the length of a swimming pool. There are some other guides we can use. A typical family car is approximately 4 metres, and a double-decker bus is approximately 15 metres. So the official stopping distance at 70 miles an hour is about 4 swimming pool lengths. This graph shows different speed limits or different speeds of your car up the left-hand axis, and it shows distance across the x-axis across the bottom. We're going to zoom into the graph and we'll bring back our unlucky pedestrian who's going to step into the road. If you were travelling at 20 miles an hour, that's the green line, and a pedestrian stepped out in front of you 10 metres ahead, by the time you've thought about it and brought the car to a stop, you would have travelled 12 metres. Remember, the pedestrian was only 10 metres ahead. So you will hit the pedestrian, but you will be doing a very low speed of maybe 2 or 3 miles an hour. If you were travelling at 30 miles an hour, by the time you've thought about it and hit the pedestrian, we're looking at the orange line here, you will still be travelling at more than 25 miles an hour. That's going to cause some damage. And if you were travelling at 40 miles an hour, well, you wouldn't even have had time to start slowing down. You'd still be in the thinking phase before you hit the pedestrian. So the pedestrian would be hit at 40 miles an hour. So the key points here are: the faster you go, the further the car will travel before you've even got your foot onto the brake pedal. And as you increase your speed, it takes significantly longer and further to bring the car to a stop. So I hope that's given you a better understanding of overall stopping distance and what we mean by thinking distance and braking distance. You may be unlucky on your theory test and get a question that asks specifically about the braking distance rather than the overall stopping distance. You can work it out from overall stopping distance, take away thinking distance, but personally it's likely to be one question. I think we can afford 1 mark to be lost. So I hope you've enjoyed today's video, and we'll see you again very soon.